Hello, Algebra 2 students. I appreciate you getting time or finding time to get your notes taken care of. Today we're going to be reversing the process we worked on last time. Instead of using the equations to find the graphs, today we're going to be seeing if we can use the graphs to find the equations. So our title for today is Writing Equations of Rational Functions. Please copy down the title as well as the objective. And our objective for this day is the student will learn to construct equations of rational functions based upon characteristics of their graphs. As always, anytime you need more time to get something copied down, press pause and then hit play when you're ready to move forward. So let's get started. Recently, we have learned how to convert equations of rational functions into their graphs. For some reason, this proved to be a little bit more of a challenge than it should have for many of you, because all that it was involved with doing that is plugging x values into an equation to find out what y is doing. We've been making that much harder than it actually is. It's just plug and chug math. You have a formula, you plug in a number to see what the other number does. Okay, that should be a fairly easy chore. Okay, but the issue becomes what happens if you do not know the equation and all you happen to know is information about the graph. Okay, well, very similar to what we did last unit, okay, with the square root function, we are simply going to compare known characteristics about the parent function to the characteristics of whatever graph it is that we are looking at. Okay, so there is a graph of the parent function. This is a graph that you have in your notes, so you do not necessarily need to copy this one down again. You should have it from the notes last time. So we'll be comparing characteristics of this graph to our new graph, and then asking ourselves the pertinent questions. What would that look like if we saw those characteristics in the equation? Y equals a over x minus h plus k. Now, as we've already said, the challenging part of determining what is going on with these hyperbolas is the speed. Okay, the speed is the hardest thing to determine. There's really only a limited amount of information that's going on with these graphs. We can move the center point around. That is easy enough to recognize. We can turn the graphs backwards or upside down, which we said is actually the same thing whether you reverse the axis left to right or reverse the axis up to down. You end up with the same end result. Okay, so it's easy to see if the graph has been flipped in some manner. Okay, so the challenge is going to be determining what is going on with the speed of the graph. Okay, so in order to do that, let's take a quick look at the parent function and its speed. Okay, so obviously, if we consider this kind of baseline, okay, if the x does not change at all, okay, in the parent function or from the parent function, then obviously y does not change at all. Okay, however, if you make your x value move 1 unit either way on the x-axis, okay, so we're moving 1 full step away from the center point of the parent function. Okay, it is no longer the parent function because we're moving, but as we move 1 step in either direction on the x-axis, that actually causes 1 step also on the y-axis. Okay, so as x changes plus or minus 1, y also changes plus or minus 1. Okay. However, it's not as simple as x will always match y, because if you remember, the rational function is a reciprocal relationship. Okay, so if we move 2 steps away from the center in either direction on the x-axis, then that is going to cause the reciprocal of 2, which is 1 over 2, steps in the y direction. So moving either +2 or -2 on the x-axis away from the center is actually going to cause the parent function, or the y value, pardon me, to move plus or minus 1/2 step away from its midline. And similarly, if you move 3 steps either direction away from the center, as far as the x-axis is concerned, that's going to cause a reciprocal relationship with the y-axis. So as we move 3 steps from the x-axis one way or the other, that's going to cause 1/3 of a step away from the center on the y-axis. Okay, and this relationship will continue on and on and on. Okay, forever, for as many steps as we would like to take. Now, please keep in mind that the y values, okay, that is the distance of the change from the horizontal asymptote. Remember, there's a vertical asymptote and a horizontal asymptote passing through our center of our hyperbola. Okay, so these x values on the left, that is saying when we move 1 step, 2 step, 3 steps, either direction away from that vertical asymptote, it is causing these step sizes over on the right. Okay, 1 step, 1/2 a step, 1/3 of a step up or down away from the horizontal asymptote. And as we said, clearly there are plenty of more values because our hyperbola goes on infinitely. So we could continue 4 steps, 5 steps, 6 steps, and so on, and it would continue the exact same relationship with the y-axis, 1/4 of a step, 1/5 of a step, 1/6 of a step, and so on. Okay, so we should be really very clear about how the parent function moves. As x increases 1, y increases the reciprocal of 1. As x increases 2, y increases the reciprocal of 2. Okay, so let's see it in action. In order for us to be able to write an equation, we are going to either have to be provided with the graph or provided with the coordinates that go along with the graph. And in most cases, you will probably find that you are provided with the coordinates because of all the fractions that can be involved with a rational function. Okay, so in all likelihood, they're probably going to plot you the points in the form of an XY chart, or maybe in the form of a word problem that relates an x-axis to a y-axis in some way. Okay, so what we're looking at here is we have a set of points that are provided for us. Okay. Now, if we just kind of logically progress through this, our first step would be to convert the plottable points over to the graph. Okay, now we were provided with 7 lines worth of information in the chart, and only 6 of those are able to result in plots in the graph. Okay, and obviously you should be at least getting the general idea of the hyperbola that is forming there, so we can connect the dots and just kind of guesstimate what the remaining tails of these components of the hyperbola are doing. Okay. And that should probably lead us to this 7th piece of information from the chart, and that would be this ordered pair that is sitting in there that's not really an ordered pair. We have x having a value of 1 and y having an undefined value. Now, what would cause y to have an undefined value? Well, that would be the existence of an asymptote. Okay, the denominator of this function went to 0 when x tried to equal 1. So there's a vertical asymptote passing through the graph, and I've marked it in the graph. Now, by conducting some basic kind of common sense calculations, okay, we ought to be able to surmise that the horizontal asymptote would have to follow the line y equals +2. Keep in mind, the 2 legs, or the 2 aspects of the hyperbola that we're looking at, they're going to have to be equidistant from both of the asymptotes because of that reciprocal relationship that's going on between x and y. Okay, so we can position the asymptote, the horizontal asymptote, in the graph at y equals 2. This should be pretty much a dead giveaway of where the center of the hyperbola is at. We ought to be able to very easily state that the center is at 1, 2. Okay, so that gives us h and k. Those are important pieces of information. Another important piece of information would be to determine what the direction of the graph is doing. Now, we've already said it really does not matter whether you reverse the y-axis or whether you reverse the x-axis because of the symmetrical nature of the hyperbola. Okay, either reversing the x-axis or reversing the y will result in the same graph. So what we really need to do is just ask ourselves, is this hyperbola positioned in the idea of quadrants? Is it positioned the same way that the parent function is positioned? Now remember that the parent function, the two aspects of the hyperbola were in quadrant 1 and quadrant 3. Okay, so if you look at the two asymptotes and think of the asymptotes dividing our graph into 4 quadrants, does our hyperbola exist in quadrant 1 and quadrant 3 with respect to the asymptotes? Yes, it does. Okay, so they are in quadrants 1 and 3, so the direction has not been changed. There's no need for a sign change. Okay, the positioning is correct. Now we said that the only real chore would be to determine if there has been a change in speed in the graph. Okay, so now let's look at the graph itself. Okay, we said that as x moved one step, one direction or the other away from the center. Okay, so that would be 1 unit either direction away from the center. We said that the y value should change the reciprocal of that one step. So as x changed by 1 unit, y should also change by 1 unit. Okay, do we find a point on the hyperbola at the end of the arrows that we just drew? We did not. Where is the point? The point is actually another whole unit away. So we expected it to be 1 unit up from the horizontal line, or the horizontal asymptote. It actually ended up 2 units. So it's actually twice as far as it should have been. What happens if we move 2 units away, okay, from the center point? 2 units on the x-axis, the y value should change the reciprocal of 2 units. That would be half a unit. So we expect the point to be basically at those locations. Is it there? No, it's not. It's all the way at a whole step instead of a half. So once again, the point is twice as far away as we expected it to be. Okay, we could even continue this on. 3 units each direction, 3 units each direction. Okay, the point should be up. The reciprocal of 3 would be 1/3. Okay, looks closer to 2/3. Okay, so once again, the point is twice as far away as we expect it to be. That is a pretty good indication that our speed is moving twice as fast as it was intended to. Based upon this information, we ought to be able to construct an equation. Y equals, the numerator should reflect the speed. Okay, so our speed is twice as fast. That's a 2. The denominator should have x minus the h value of the center of our hyperbola. Our center is at 1. So our denominator is going to say x minus 1. And outside of that fraction, we should have plus the k value of our center, and that is positive 2. So our equation is y equals 2 over x plus 1 plus 2. Oh, sorry, I have a sign error in my notes. I should have said it should say x minus 1, but my notes actually say x plus 1. So please make that correct. Write that down correctly in your notes. Okay, let's look at one more. Not quite as much explanation this time. Okay, there's our points. We should be able to very quickly identify where the vertical axis or the vertical asymptote is going to be. Okay, looks like it's going to be at x equals 3 because that denominator is apparently becoming 0 right there, causing that undefined location. The other 6 points we ought to be able to plot. So taking them over to the graph, there they are. They are not moving very fast, okay, but we can recognize that the vertical asymptote is going to be at x equals 3. That means that those legs of the sides of that hyperbola are going to approach x equals 3, but not actually reach it. So they're going to have to turn very sharply in order to stay away from the asymptote, which is there. Now, quite obviously, the horizontal asymptote is going to have to pass along the line y equals -1 in order to keep the symmetry of that hyperbola in place. Okay. So we ought to be able to start to identify our information. Our center is going to be located at 3, -1. Our direction. Okay, is our direction the same as the parent function, or has something been changed about it? Okay, well, our parent function typically exists in quadrants 1 and 3 with the rational function. Comparing this graph to its asymptotes, we're not in quadrant 1 and 3, we're in quadrant 2 and 4. Okay, so our graph has been reversed in some manner, and we've said it does not matter which variable we reversed. Okay, so we'll get to that here in just a second. Okay, and the speed of the graph. Okay, from the vertical asymptote, or from the center, as we move one step out on the x-axis. Okay, we move one step out, one step out. Okay, y should move a full step and a full step. It does not move a full step. It looks something closer to half a step. So it looks like we're moving half as fast as we should. As we move 2 units out, 2 units out, we should be, the y value should be changing the reciprocal of 2. That would be 1/2. Well, 1/2 is actually a little higher up than that and a little lower down than that. So again, looks like it's maybe moved a fourth. That would be half as much as it should have. Okay, and again, same reasoning, same line of thinking. It looks like the speed is only moving half as fast as it should have. Okay, so we ought to be able to construct an equation based on this. Okay, in the numerator, okay, is our speed. Well, our speed is 1/2. We cannot put a fraction into the numerator of a fraction. Okay, so the numerator of our speed is going to go in the numerator of our fraction. The denominator of our speed will go in the denominator of our fraction. So we should have 1/2 times, and then you have your x minus h information. Well, what is x minus h? Well, we got x, and then we're supposed to have a minus, and then we should have the h value of our center. That's a 3, so we should have 2 times x minus 3 in our denominator. And then hanging on to the back end of the fraction, we should have our k value. It's supposed to be a positive, but the k value is -1, so we should have a -1 hanging on to the back. Okay. Now, in order to represent the reversed idea, the reversed nature of this graph, we have the sign change. Okay. So I'd simply just put a negative up in the numerator, or you could put it out in front of the fraction. Either way would get your reversal of your quadrants the way we need this graph reversed. Anyway, I think you can probably get the idea of it. It's just a matter of walking your way through the graphs, asking yourself the questions that must be asked so that we can write the equation of our rational function. I appreciate you getting time to get your notes taken care of, and I'll see you in class.